All right, let's jump right into this explainer. We hear about AI all the time, right? But if we actually strip it down to the bare metal building blocks, it really reveals exactly why this tech is advancing so incredibly fast right now. So let's look at the foundational architecture driving what's probably the most significant technological shift of our time. Think about it. Have you used Siri, maybe watched Netflix, or just unlocked your phone with Face ID today? If so, you've already interacted with the systems that laid the groundwork for where we are now. These everyday tools were the crucial precursors to the massive foundational models dominating the landscape today. It's not magic, it's really just human-made logic operating at a completely breathtaking scale. To break this all down, we're going to cover defining the dream, ancient origins, the binary brain, data as fuel, and finally, the narrow reality. So, Section 1, defining the dream. What actually is AI? At its core, artificial intelligence is simply technology that lets machines simulate human intelligence. Things like learning, problem solving, and making decisions. But the coolest part is the fundamental shift in how we're doing this today versus the early days of computing. We've basically moved away from hard-coded, rigid rules where a programmer had to sit there and manually anticipate every possible scenario. Instead, we're building these dynamic neural networks that rely on super sophisticated pattern recognition. This architecture lets the machine actually adjust and optimize its own internal weights and biases as it processes info. It's essentially learning the shape of the data, rather than just blindly following a fixed script. Moving right along to part 2, ancient origins, myths to machines. It's wild to think about, but thousands of years ago, the ancient Greeks were already dreaming this stuff up, with myths of Talos, right? This giant bronze robot designed to protect the island of Crete. Fast forward a bit to inventors like Hero of Alexandria building literal mechanical automata, these water-powered machines that actually appeared alive. But the real paradigm shift hit in the 1800s. Charles Babbage designs the analytical engine, a mechanical calculator, and then Ada Lovelace realizes, hey, these machines can actually process symbols to solve complex problems. Her insights separated the physical hardware from the programmatic logic, effectively inventing the entire concept of software. Which brings us to Section 3, the binary brain, how computers think. Now, we all know that fundamentally computers operate on a binary system of zeros and ones, representing the on and off states of tiny transistors. But what's absolutely crucial to grasp right now is the sheer mind-bending scale of this architecture. We are looking at models operating with hundreds of billions, sometimes even trillions of parameters. The core engineering challenge isn't just flipping electrical switches anymore. It's the insanely complex math required to take all the infinite richness of human language, spatial reasoning, and logic, and crunch all of it into high-dimensional binary vectors that a silicon chip can actually calculate. Just like the quote says, behind literally every app, game, website, and AI system is a simple language built from just two numbers, 0 and 1. When you scale that up to these massive data centers processing billions of these simple binary instructions at near light speed, you cross a major threshold. That immense velocity and sheer volume is exactly what creates this seamless illusion of human-like thought and instantaneous generation. Okay, on to Section 4, data as fuel. What AI eats. You hear it all the time. People love to repeat the cliche that data is the new oil. But honestly, let's subvert that a bit. Because unlike oil, data is infinitely replicatable. A text post, an X-ray, or a financial score can be duplicated endlessly without running out. However, high-quality, accurately labeled data is rapidly becoming a super scarce commodity. As we train increasingly massive foundational models across text, image, and audio domains, the bottleneck isn't getting enough raw data. It's actually curating the pristine datasets required to teach these models effectively. The basic workflow is still pretty straightforward, right? Collect data, identify patterns, make predictions. But the frontier has shifted massively in recent years. We are largely moving away from supervised learning, where human workers had to painstakingly label every single piece of data, and diving headfirst into self-supervised learning. Now, engineers just feed massive streams of raw, unstructured information into the system, and the AI finds the hidden structures totally on its own. It essentially learns the statistical probability of what should come next, whether that's predicting the next word in a complex sentence or generating the exact right next pixel in an image. And this brings a whole new level of severity to the old golden rule: garbage in, garbage out. If an AI trains on poor quality, incorrect, or biased data, the outputs will inherently fail. period. Today, this basic rule connects directly to a cutting-edge problem known as model collapse, because as the internet rapidly fills up with AI-generated content, new foundational models are accidentally scraping and training on the synthetic outputs of older models. Without a constant stream of fresh, high-quality human-generated data to ground it in reality, the system's accuracy rapidly degrades and just flattens out over successive generations. All right, let's move to our final block, Section 5, the narrow reality, what AI actually is today. Look, everything we interact with right now is narrow AI or weak AI. These are systems custom-built to perform specific tasks extremely well. Think of narrow AI like a highly trained Olympic swimmer. They are absolutely incredible in the pool, but you definitely wouldn't ask them to fly a commercial airplane. An algorithmic trading bot can execute millions of microtransactions in a single second, and a system like AlphaFold can solve complex protein structures that eluded scientists for decades, but they cannot think even 1 inch outside of their specific algorithmic lanes. And this contrast perfectly highlights the vast chasm between the narrow AI we have right now and that hypothetical artificial general intelligence, or AGI, that the tech industry is so aggressively chasing. Human intelligence is just incredibly broad. We learn from rich, multi-sensory life experiences, we possess genuine creativity, and we can naturally adapt to entirely unexpected situations with zero prior training. Narrow AI, by contrast, relies purely on its specific data diet and follows rigid programmed systems. It can calculate complex mathematical vectors infinitely faster than the human brain ever could, for sure. But it completely lacks the generalizable common sense required to navigate an unpredictable world. So, here's the big question I want to leave you with. Are we going to rely entirely on these highly optimized narrow algorithms? Or will they remain just a really powerful tool that amplifies our own human creativity? Figuring out how we balance our broad, adaptable intellect with the immense data-driven power of these binary systems is basically going to define our entire next technological era. Thanks so much for joining me for this explainer.